All right, guys, so these are problems 1 through 6, answers and how to work through them. Woo! Okay, just came back up here after watching a little volleyball here on Thursday. So, work through these real quick. Let me get my calculator. Okay, so I already walked through 1 through 10 on the video that's posted right before this. Calculator, so I have it. Okay, and we'll work through these real quick too as well. All right, so number 1. You got sodium 24 has a half-life of 15 hours, okay? How much does sodium 24 remain in an 18-gram sample after 60 hours? So 15 into 60, you can do the math, but 15, 30, 45, so it looks like 4 half-lives, 4 half-lives, okay? So I went through 4 half-lives, and it said how much sodium will remain when I started with 18, so if I had 18 grams, go through 4. 1, 2, 3, 4. All right, goes to 1 half-life. Goes to 9. Goes to 2 half-lives. 4.5. Goes to 3 half-lives. 4.5 divided by 2. Yeah, 2.25. I didn't want to mess it up. And one more time, divided by 2 for the 4th half-life. Gives me an answer of 1.125. It said in grams. Yep. So the answer was, like I said, if after 60 hours with a half-life of 15, that'd be 4, started out with 18 grams, want to know how much of the sample was left? 1.125 grams. All right, so number 1 was 1.125 grams. Okay? All right, that's number 1. 1 to 6. Okay? Pretty straightforward. Okay? All right? Let's do number 2. After 42 days, you have 2 gram sample of phosphorus 32 contains only 0.25 grams. So, for 2 grams, so let's just figure that out. If I got 2 grams, 1 half-life gives me 1 gram. 2 half-lives gives me 0.5 grams. 3 half-lives gives me that 0.25. Okay? So that's what I have left here. All right, so we know it went through 3 half-lives to get to that amount from that what it started with. We know it took a total of 42 days, so it wants to know what's the half-life of it. So what's 3 into 42? 42 divided by 3, 14. So we know the half-life of phosphorus 32 is 14 days, okay? Because I knew that, all right, I remember once again, I had 2 grams to go 2.5. It went through 3. So 3 half-lives, if that was the total, 3 into that. So that means 14, 14, and 14 gives me a total of 42. So number 2 is 14 days. Okay? That's how I got to that. All right, that's 2 down, 4 to go. All right, 2 down, 4 to go. All right, number 3, polonium-214. With relatively short half-life, real fast one, 164 seconds, okay? So how many seconds would it take for 8 grams of this isotope to decay to 0.25? Okay, that looks like it's gonna maybe a lot, so let's just do this, okay? 8.0 I started with. 1 half-life, 8 goes to 4. 2 half-lives, 4 goes to 2. Well, that's going pretty fast. 3 half-lives, 2 goes to 1. 4 half-lives, 1, half of that is 0.5, okay? 5 half-lives, half of 0.5 is 0.25. Okay, so that's not too bad. So yeah, it looks like 5 half-lives, okay, to get from 8 grams to 0.25 grams. And if each half-life is 164 seconds, well, just time 164 times 5. Times 5. So on my calculator, 164 times 5. 820 seconds. You could have put it in minutes. I'm fine. 820 seconds because it gave it to you in seconds. But if you wanted to put that in minutes, you could convert it if you want. So, but 820 seconds is how long it would take for 8 grams of polonium-214 to decay down to 2.25 grams. Okay? 3 down, 3 to go. Okay? 3 down, 3 to go. All right. Number 4. How many days does it take for 16 grams of palladium-103 to decay to 1 gram? Okay, So it says the half-life is 17, so we know that's, we just need to know how many half-lives it took to get there. So make it simple, there's 16. Let's start halving. There's 1, 8 goes to 4 is 2, 4 goes to 2, there's 3. 1 is after 4 half-lives. Oh, I'm there. So I went from 16 grams to 1 gram, 4 half-lives. So 17 times 4. 17 times 4 is 28, 2, 4, 68 days. All right, so number 4 is 68 days. 68 Danarinis. Okay, pretty simple again. All right, pretty simple again. All right, number 5. 5. Cinco. All right. By approximately what factor would the mass of a sample of copper 66 decrease in 51 minutes? So the half-life of copper 66 is 5.10 minutes. Okay? So half-life is 5.10 minutes. That's a half-life, 5.10 minutes. Okay? And it wants to know, if that's a half-life, how much of the mass of the, approximately what factor, the mass. So you can give me a percent or a fraction, I'll give you both, okay? Because it's not giving me a value, but I can solve it. Just visualize it as a circle graph, 100% of that sample of copper 66. So 1 half-life's that. We just want to know after 51 minutes, what percentage or fraction is left. Okay, we can do this. So 5.1, we'll just add them up to. So 5.1 plus 5.1, that's 2, plus 5.1, that's 3 half-lives, getting there, plus 5.1, that's 4 half-lives, plus 5.1, that's 5 half-lives, 6, 7, 8, 9, 10, 10, 51. So this thing went through 10 half-lives. Okay, so you got a really tiny fraction or a really small decimal or percentage. So we can just go, this would be this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. 32, 64. 64 times 2 is what? 121. 64 times 2. Yeah, no, that's not right, Jay. 2, 1, 2, 3. Oh, shoot. We do this again. Duh. It's been a long day. It's 6:30 right now on Thursday night. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 over 1,024. So if you were to divide that into that, you can get a really small number. I'm good with the fraction on this one, but some of you, if you did the decimal, it would be 1 divided by 1024. So that would be like 0.00097,656. Okay? So that's a really tiny part left of that, okay? Because once again, refresh that, it was kind of me, lost my train of thought there. If a half-life is 5.12 minutes, and I want to know approximately what factor would the mass of a sample of copper be after 51 minutes, so I just figured, all right, I can do it real simple, or I could try and do the fraction. It doesn't matter how you solve it. So I just said, all right, 5.1, and added them up, times 1, 2, 3, 4. So if you do if you want to check my math and go 5.1 times 10, which would have been easy, obviously, times 10, 51. Oh, you could have done that math. So it was definitely to the 10th. So that's the fraction, that's the decimal point. So it's 1 over 1024. Or you can do the decimal, which would be 0.000976656. Okay? And that was number 5. So we got 1 left. Last of the Mohicans here. All right. One of my favorite movies, by the way, if you've ever seen it. Good book to read. Probably never have. Okay? But I really like it. All right, number 6. But I could be wrong. All right, last one. So I got 5.49 seconds, oh, okay, in 5.49 seconds, 1.20 grams of argon 35 decays to lead me to this. What is the half-life of it? Okay, so if I got 1.20 grams, all right, and I just want to do the old division of that to make it even easy, 1.20 divided by 2. So 1 is 0.6, that's one half-life, divided by 2, that's 0.3, divided by 2, that's 0.4, is that what I wanted? Yeah, 0.15. So that was, it looks more difficult than it was, but it was only 3 half-lives, okay? So what is the half-life of argon? So 5.49, really fast, 5.49 seconds. It went through 3 half-lives, so just divide 3 into that. So I got 5.49 divided by 3. Each half-life is 1.83 seconds. 1.83 seconds. Let me check my answer. That was the total time. That was what I had. It decayed to this, which took 3 half-lives because I did that. 0.15. So what is the half-life of argon? So I just divided 3 into that to give me that. Yep. Okay. So that is 1.83 seconds. Okay. So that is the last of the homework that was due today. I'm sorry, tomorrow, Friday. All right. And where you can check these. And I will obviously have that. I told a couple of you that this first set I'm a lenient on. I realize first time doing it, I don't expect you to have it down perfect the first time. But the next set that you'll be assigned to today, okay, that'll be due on today. I think I have them. I'll probably have them due on Monday or Tuesday because I want to have a little quiz over it probably. Okay. So anyways, but yeah, I'll probably have them due Monday, yeah, for the weekend, because most of you get this done in class. Most of you will get those done in class on Monday, but those will actually be exactly like what I said, answers, because that'll be your second set of problems. You've got to check these 1 through 9 and 1 through 6 and everything. But once again, I didn't give you any problems with the plus or minus like I did in the sample to teach this to you today. Thursday, right, of that plus or minus 10%. But let's pretend if I had, let's say the date was 3,450 days. I'm just making something up, and I asked for the plus or minus margin of 15%. Okay, this is just a little extra bonus practice. So I would go 3,450. Turn this into a decimal, 1, 2, times 0.15, which is going to give me 15% of this. 15% of this is 517.5. So then I want to know the high and the low here. So if my base is 3,450, so I take 3,450 plus extra 15%, which is 517.5, so that would be 3967.5. Then I would need the low, which is 3450, minus 517.5 equals 2932.5. And that would give me the high, low, and days if I was doing this, same like that woolly mammoth one where I'd say, okay, that whatever it is that we radioactive dated is between just under 4,000 days and 3 and 4,000 days old. That's that plus or minus. And I did 50 instead of 10%. Remember, find it at the base, add it to the base to get the high, subtract it from the base to get the low. Okay, just a little review on that. Because I know you'll have one, at least one of them, on the quiz when I give it, where you have to tell me the high, low margin for error. Okay? All right, so that's finished for those. Oh, and here, real quick, there's the answer. Number 1, 0.125 grams, 14 days, 820 seconds, 68 days, 1 over 1,024 through that 0.009765.6, and then 1.83 seconds. Okay, done.